Hi, my name is David Levy. I'm a technology engineer with IBM, and today we're going to build an application on AI applied. Today I'm going to walk you through the process of creating a React TypeScript UI, setting up a TypeScript Express server for handling UI logic, and integrating it with a Python FastAPI backend that leverages generative AI capabilities by creating a pet naming suggestion application. Let's get started. So when we come here, we can see right away that this is our application. It's asking us to describe our future pet, and it's going to give us a suggestion for its name and also a reason why it did it. So I think I'm going to get a dog. It's going to be a girl, and she's going to be sweet, cute, cowardly, sleeps under my bed, and keeps me up at night by talking to me. Very weird animal. So let's see what kind of name we get back. Lady Gobbledygook. And then it gives us a reason why it named it such. Now, in order to get an LLM to respond in such a way, we're going to have to work with a few different things. One is prompt engineering. And the way we're going to do that is we're going to go to the Watson XAI prompt lab. So let's start there. First, I'm going to show you a summary generation prompt example. So right now, I'm asking it to summarize the history of bicycles. And when I click generate, it gives me exactly what I want. And the way I've accomplished this is first by giving a clear and concise instruction, and then also using something called few shot examples. So we give a long string that we want to be summarized, and then we give the example of what we're expecting back. So we do that a couple of times, so when we ask it to do live generation, it provides the answer to us exactly the way we want it. One of the things I want to show you within the Watson XAI prompt lab is that we have options for model parameters. And also, we have a view of the code, which is going to come in handy when we want to transpose this to our FastAPI. So let's clone our repo, and we'll start working on the FastAPI. So when working with Python, it is a good idea to set up a virtual environment. The way we could do that is I already have one set up, and we're going to just activate it. And then we're going to install the requirements file that's located inside of the repo. Perfect. So now that we have the GitHub repo cloned on our machine, let's first install the Python dependencies. Now that when dealing with Python, what is good practice to do is to install dependencies of any kind of project into its own virtual environment. And what this is going to do is going to create its own segmented environment with no packages installed at all, and which we can then use to install all the unique packages that we have in this particular repo. So now that we've created the virtual env applied AI, let's activate it. And we can see right on the screen that we're now within that virtual environment. And the next thing we have to do is install the requirements txt, which is just a frozen dependency requirement file. So we're just going to hit and install it into this particular virtual environment. Now that we've installed the dependencies for our FastAPI, we're going to copy the .env example and create a new .env. In the .env, we're going to want to grab the API key, the project ID, and the URL that we can find in the Watson XAI prompt lab. So if we go to the code, we open it up, we can grab the project ID right from the curl. And for the API key, we go back to our identity and access management from our cloud. We get there by the manage dropdown, go to API keys and create a new API key. Never share your API key. Don't ever push it up to GitHub. You'll get in trouble. And now that we have this, we can start up the application. So from our API directory in the code repo, we can run the command unicorn server app and do fast reload. This is very good for development. But we can go to our Swagger UI, and you can see that we have a couple of pre-built routes in the repo we've provided for you. We have a health route just to make sure that the FastAPI is up, and you can see that it's up. And then we also have that generate summary endpoint. And we have that there just to recreate exactly what I showed you from the prompt lab, where you have, instructions, you have the few shot examples, you have the data, you send the data and you get a new summarization. I wanted to show how to actually apply that in the FastAPI. And with FastAPI, you have these routes that you could test against, and you can see exactly what we're looking for. So we're looking for a template model, and we're looking for a prompt template name, and then we're looking for additional keywords. And I'm going to show you exactly how to use it from this Swagger UI. So we're going to send over the exact thing that we had, the history of the bicycle. We're going to send it over as data to our FastAPI, and we're going to ask it to summarize it. And now it's hitting our FastAPI, and it provides us a nice summarization. How do we do that? There's a couple of components within the FastAPI that I want to show you. So if you look at the way the application is structured, we have a data directory. In the data directory, we have a couple of additional directories, one called an examples, one called models, and one called prompt templates. Each of these, I have used the prompt lab to dictate what I put in there. So I'm basically just transposing what I've done in the Watson XAI prompt lab into the application, and that makes this process so much easier. So if we look at the model, we can see all the parameters, the ID for the model that we're using, the parameters for decoding and min-new tokens, etc. And if we look at our prompt lab and open up the view code, we can see all of the same information. So basically what I did was I copied what was successful for me in the prompt lab, transposed it into my application, into that model's JSON, and used that as the model parameters for my endpoint call. Similarly, we have all of these examples, right? Like we're using FewShot to implement better responses from the LLM. So the way we can do that is similarly name it generate summary as a text file, and we have these examples identical to the ones we have here. And the reason I'm doing this is because we're going to be building this iteratively, right? Like we want to be able to go directly from Watson XAI into our code base and then integrate it with the UI and just be able to work really, really quickly. It's just a very nice pattern to use to get really great results when dealing with something like an LLM. Lastly, we have the prompt template. Now, a prompt template is something that we can use to give instructions, use the examples that we've placed, and take the data that we're sending via the API and send all of that to the LLM to return back the responses we're looking for. So if we look at that, we have the instruction, summarize the following text. We have the examples. We have the input, which is that data that we're sending directly from the that endpoint that we showed in the Swagger docs. And that's exactly how we implement it. Now, what we're using it as is in the server.py file. Here you can see the generate summary endpoint. We're looking for 3 parameters: the template model, the prompt template name, and the prompt template kwargs. Now the template model is defaulting to generate summary, and that is because in the data directory, those are the names of the files that we're using. If you look at the functionality in the repo when you get it, you'll see that we're looking at these directories. We're grabbing the names of those directories and using those as the key to a dictionary that we're going to return back to us when we hit it with the correct parameter. So if we look for something that says generate summary, it's going to grab the examples generate summary, it's going to grab the model generate summary, and it's going to grab the prompt template. And from here, we have a utility function called generate text response. And from here, there's a lot of functionality that's going on, exactly what I said. It's going to say, look at that template model that we're sending in a parameter and grab that model information from that JSON. Same with the prompt template request, and same with the examples. A little bit different with the examples, though, because you're not going to want to use examples for every API call or every watsonx AI call that you make. So we have the option just to leave that as blank. So if you don't have any few shot examples, no problem. And after this, we're going to use this method called getModel that's in a class called ModelRequest. Now this is where we're going to be working directly with the watsonx AI SDK. So you could look at exactly what we're doing in the documentation on watsonx AI. But very basically, you have the model ID, which is the model name, your credentials and your parameters, and your project ID. Now, a little bit different here is that we're going to add this into a LangChain invocation. So we have to wrap that model inference within a watsonx LLM wrapper, which makes it runnable within the LangChain. So if we go back to the server, we can see that we have this chain, which is starting with the prompt template, grabbing that model, and then ending it with the output parser. The output parser is something that's provided to us by LangChain, and it's going to provide a string from the response. And once that is done, we call it and we return it as generate text. Once that is completed, the function returns back something called generate text, which is just a string, which you can see in this response body. So the next thing we're going to do is now create a new endpoint called petNamer. Now the reason this is going to be a little bit different is that we're going to want to coerce the model to return back JSON. And if we know LLMs, they're not the easiest to ensure that we always get the data structure we're expecting. So what we're going to pull in is something called a Pydantic output parser. And we have this here. It's part of the LangChain package, but Pydantic is used throughout this application. And I could even show you something really quickly. So if we go to the generate summary endpoint, and we want to add a new class to ensure that everything that comes back as a response from generate summary is in this JSON format, we can add a new class using Pydantic. So let's try that out really quickly. I'll add a generate summary response.py. We'll open up one that already exists. And we're going to rename it from JSON response to generate summary response. We're going to only be using the base model. And what we want to return back is a object that has a generated text field that returns back a string. Now what we could do here, let's import it into our init. So from generate summary response, we're going to import the generate summary response. And if we go back to server, let's import it as one of our schemas. And if we go back to the generate summary, we can say that every response we want from this route, we want it to be in that exact shape, that exact JSON shape. And now this is good for obviously a mixed team, because if we know exactly what's coming in and exactly what's coming out, it makes coordinating our code much, much easier. So what we're going to do is we're going to take that class and we're going to add it as a response model to our endpoint. And when we go back to our FastAPI docs, we can see that now the expected output is going to be this JSON object with a generate text field and guaranteeing a string output. The way we can utilize this Pydantic class pattern to coerce the model to return back JSON objects is by using the same exact pattern. And instead of doing just the straight string output parser, we're going to use a Pydantic output parser to say, this is what we want the response to look like. So let's create that right now. We're just going to copy and paste our generate summary route and rename it to generate pet name. And if we look at the way that we have the generate summary response, we could take something that I've already written out, which is called the JSON response template, and we're going to add another class called generate pet name response. And we're going to say generated text equals this JSON response class. So the output of this generate pet name is going to be almost identical to this string, which is going to give us this object, which is going to give us a name and a description, but it's going to be a field within an object that we're returning. So if we want to see that in action, we can see exactly what we're going to get back. Hold on, let me just rename this to generate pet name. We're going to reclassify this route as a generate pet name based on some descriptors. And now we can look at our Swagger documentation, refresh it. We're going to have a brand new route in here called generate pet name. And if you look at the shape of the data that we're supposed to get back, hold on. We actually have to import it first. So first we just have to grab the generate pet name response from the schema and import it into our server.py to be used by our generate pet name endpoint. So let's go to our generate pet name response and add it. Everything looks good. And now we should see exactly what we're looking for. We're going to receive from the response, we're going to see, we're telling anyone who's using this route that we're going to receive something that looks exactly like this. It's going to be a JSON object, and we're going to have a name and a description, and the name is going to be a string, and the description is going to be a string. So the last thing we have to do is let's use that utility function that we used for the summary, and we're just going to make one minor change. So let's change this from generate text response to generate JSON response. And instead of using the string output parser, we're going to use the Pydantic output parser, and we're going to force it to use Pydantic object equals the JSON response template. And from there, we're gonna grab, and I'll show you exactly in the documentation where that is. So if we look at Pydantic, if we look at exactly the Pydantic parser documentation from LangChain, we're gonna grab something called the format instructions. And the way we get that is that when we define the Pydantic output parser and we give the Pydantic object the class we're using, and this time it was a JSON object, we can just grab the get format instructions from that parser, and that's what we're going to use. So let's call it format instructions equals parser.get format instructions. Perfect. And this is going to be a string. Okay. So the next thing we have to do is now we just have to add the examples, the model, and the prompt template. So now that we've used the Pydantic output parser to try to convince or coerce the LLM to return back a JSON object to us based on that class we just created, we have to update the way that we're making prompt template and the way we're using the examples. And of course, we have to grab the model parameters from the prompt we've worked on in order to get the correct responses. So let's go back to the Watson XAI prompt lab. And this is the prompt that I'm going to transpose from the prompt lab into our code base. So we can see that we have the instructions, we have the few shot examples, we have the parameters that we've set, we're using sampling, and we also have this curl is where we're going to take all that information. So let's go to our code base. We're going to create a new model file. So let's name it petnamer.json. We're going to name a new examples file, petnamer.txt. And we're going to make a new prompt template. You guessed it, petnamer.txt. So in the examples file, we're just going to grab we're going to grab the few shot examples we have from here, and we're going to take the model the model information from this curl, so meaning like the parameters, what model we're using, etc. And we're going to create a new model file. And if you look at the way, we're just going to copy and paste from the generate summary model parameters and just create a new one and call it petnamer.json. But instead of using the IBM Granite model and instead of using these parameters, we're going to grab exactly what we're using from the Watson X AI platform. So we're using Mixtral this time. That's something that's really very helpful about the Watson X AI platform. You can just use whatever model suits your best need for whatever you're doing. I find that very helpful in engagements. And we're going to replace all of these parameters with the ones that we've been using for that prompt that worked really well. We are going to make one change from the generate summary prompt template. And this time, what we're going to do is we're going to utilize that Pydantic output parser. And what that really is, the format instructions, if you look at it, it's just a really well-crafted prompt to coerce the LLM to return back JSON. And I find that very, very, very helpful. So if you look at the way that we've structured this prompt as opposed to the generate summary prompt, we're telling it now your response should follow this format. And this format is the format instructions we have extracted from the Pydantic output parser. And so we're going to add that to the prompt template. So when it's going to grab the examples that we use, it's going to grab the data that we're sending it, but before all of that, it's going to grab the format instructions from the Pydantic output parser, which is super, super great. Makes it a lot easier. And to be totally honest, when I was building out this application, I was trying to coerce it myself with my own prompts. And a coworker of mine, Drew, showed me exactly how to use the Pydantic output parser and totally changed, you know what, honestly, it changed my life, if I'm being totally honest. So we're going to add another field, and we're going to call it format instructions. And we're going to use the format, not that. Format instructions that I have here, it's just going to be a string. So now when we return this, you can see that we're adding to our kwargs. We have the examples, which is going to be within the prompt template. The examples are going to be interpolated into that prompt. Same with the format instructions, and the data is what we're going to be sending via the API call. So let's just make sure everything looks good. We have the examples. We have the new format instructions from the Pydantic output parser. We have the chain, and we have the generated text. The only thing that we're going to do differently is we're going to return back generated. We're going to create a dictionary called with a field called generated text, and we're going to pass in the generated text.dict. So now this is going to be a dictionary. Well, let's just ensure that what we're returning back is from the generated prompt. Okay, perfect. When we look at the generate pet name, we're returning back this generated pet response. Remember, if we look at our Swagger documentation, we're expecting it to come back as generated text with that dictionary. So if all goes well, we'll be able to test this out. Let's restart our Swagger docs. Let's try it out. And let's provide it that data. And what we're expecting is something like this example. So now we're going to test out the endpoint that we just created, the generate pet name, and it's going to expect a data field with some description of an animal. And we're going to expect a response that is wrapped in a JSON with a name and a description. So let's see if it works. Great, we have Captain Sparklesbeak, and it gives us an explanation. So now we have a working FastAPI endpoint. We saw how we can coerce the LLM to return us JSON. We figured out how to create a route in the FastAPI. And the next thing we're going to do is integrate it into our React UI and our Express TypeScript backend. So now that we've finished our FastAPI endpoint, we have a generate pet name endpoint that we could send, the description of our potential pet. Let's integrate it into our front end. And so we're going to be integrating it first into our Express server. That's going to direct any calls from the React UI to our FastAPI and then return the data from it. So let's get right into it. So now that we have checked out into step 02 Express server, what we want to do is we want to go into the UI directory and we're going to install the root dependencies. Let's run the setup command. So this setup command is going to do a couple of things. It's going to create envs from examples that we have in both the server and the client. And these envs are going to be, when you're working locally, they are just going to be what they are in the examples. But what these envs are going to do, it's going to say, okay, the React UI is going to be able to talk to the Express server, and we're giving it that endpoint. And for the Express server, we also have an env that's going to say, okay, this is the endpoint for the FastAPI. Because if you think about the flow of information that you saw in the application, we're going to have the React UI, we're going to fill out a form, and we're going to hit a submit. And that submit is going to send the data from the React UI to our Express server. The Express server is going to send that to our FastAPI, and the FastAPI is going to communicate with the Watson XAI LLM, return back the response to the Express server, which is going to return it back to the React UI. That's the flow of information. So in order for that to work, we need these envs to tell the UI and the server and the FastAPI where to look and who to talk to. So now that we have the dependencies installed for the React UI and the Express server, we're going to start running them in dev mode. So we're going to go into the UI directory and we're going to run this command, npm run dev server, and that will start up the Express server. And we're going to run npm run dev client. And that's going to start up our React UI. And if you look at what the React UI was, what we're going to be starting off here is going to be pretty much totally blank. We're going to build it up and show you how to do it. But first, let's get that Express server working. So let's go into the server directory, open it up, and let's take a look at what we actually have in this in the server. We have a boilerplate code in the index, which is just a basic Express server. We also added socket.io. So having WebSockets between the client and the Express server is really very helpful and useful. We could watch databases, do anything like that, and so it's really nice. It's a nice to have, so we've added it. And then we have this middleware that's going to be using our routes. So right now we only have a config route and a DB route. Neither of them are going to be in use, but they're there if you need to use it. And we see the endpoints that we're able to hit, the API and API DB. So now we can see that the UI is blank. We're going to build this all out. First thing we're going to do is create the new pet namer route. So in your routes directory, let's create a new route. We're going to name it petnamer routes.types.ts. And let's grab the config route, which is perfectly fine as a point to start. We're going to import Axios because we're going to be making a call to the FastAPI, and I personally like the Axios package. We're also going to import .env because we're going to be using those that env to communicate with the FastAPI. And we're just going to run .env config. Okay. And if you look at your env in your server, you're going to have an API URL, which is the exact endpoint that we use to see our Swagger docs in the FastAPI. So we just have to grab that and bring it into our petnamer route. So let's just call it API URL. We're going to grab it from process.env.api URL, or it's going to be an empty string. And just make sure that it's a string. Okay, so the next thing we're going to do is let's create a post. So we can copy this config. We'll get rid of this one. We're going to turn this into a post. We're going to say generate pet name. And because this is, it's going to hit that FastAPI, we want it to be async. We're going to call, we're going to have, within that function, we're going to have the request body, the request object, and the response object. And what we're going to do is we're going to add a try catch, just add some boilerplate here for now. We'll log that error. And if we hit the error, we'll send back an internal server error. So that's status code 500, and send back an error. Perfect. One of the really useful things about setting those Pydantic classes inside the FastAPI and really articulating exactly what kind of parameters it's expecting and what it's going to be returning is that, let's say we have two people working on the same project. We have an AI engineer working on the FastAPI, and we have someone like me working on the UI. I can just go directly to the FastAPI, see exactly what we're expecting, and exactly what we're expecting to get back, and write the route to fit that. So we know that we're gonna receive something like this. So let's just copy it and bring it here for reference. We also know that this is what it's going to expect. So this is going to be the output, and this is going to be the input. Okay, so if we're going to be sending this back, let's just copy it and bring it directly into our route. We'll call it body. The data is obviously going to be dynamic, so we'll just add a data field. But before we can even get there, we have to, we know that we're going to be sending the data from the UI to the Express server. So let's just get that data first. And we'll be getting it from the request body. So we're just, we got data.body. And this is the body that we're going to be sending back. And so now let's make the call to the FastAPI. So we're going to be making a post, and it's expecting this response, this body, and we're going to be hitting this endpoint. So in order to hit that, first we're going to use the API URL that we have in our env, the localhost 8000, and then we're going to make the endpoint the generate pet name. And the backticks just mean, you know, that you could just, it's basically like an F string in Python. We're going to use the body as the request body. And then we're going to, let's see what we get back. Well, we know it's going to look like that. We're going to have generated text. We're going to have a name and a description. So let's say res.status. So this is a successful route, successful call. We're going to send back generated text, and we're going to say that's result dot data dot generated text, because we can see right here, right, we're getting this object back. It's going to be generated text, and that object's going to have name and description, which is what we're going to use in the UI. Now, if we go and look at what the end result's going to be, we also have this. We have this part called data sent to the API, which is really useful for just to see exactly what we're sending back. And if you look at the way this looks, this is going to be pretty much the same thing we're sending here. So we can just grab the body that we're sending, and we could call it our request or data sent to API. And we're going to call that body. Let's just wrap these in parens. Perfect. So what this means is, okay, we'll make an async call to the FastAPI. We're going to send it we're going to hit the generate pet name endpoint. We're going to send it this body, a template with the template model, pet namer, prompt template name, pet namer, and in the kwargs, we're going to have the data being the data we're getting back from the UI. So in the try catch, we have this async call. We say, okay, we're using Axios as the post. We're using the Axios package to make the post request. We're sending the body. And if it is successful, we're going to send back a res status 200. And we're going to send back an object with two fields, the generated text and the data sent to API. Now, a really useful tool when we're working with APIs like this is something called Postman. So first, let's just make sure we have the health route up just to show you that how Postman works. We have this health, and we could just say, okay, pet route up. Before we do that, we should import it and bring it into our routes. We'll name this pet namer. We have to actually add it to the route. So now let's see if we could actually hit it from our Postman. We got it up, pet route up. So the next thing we're going to do is just recreate what hitting the endpoint would look like from the UI. So we know that the data field when we send it from the React UI is going to be something like a male dog who is goofy and sweet and cowardly or whatever. And we want to make sure that we can send that data to the Express server and for it to hit the FastAPI. So let's make sure that works. So we have a Postman route. We say a male dog who's clumsy, drooly, and snores loudly. Let's just make sure we can hit it. I want to make sure we're hitting it here. Yep, you can see we're hitting the FastAPI. And we get that was Baron Snores. Okay. I don't know why it came up with that. I like the name. I would name my dog Baron Snores any day. But now we know for a fact that we're able to hit the Express server from the UI. We're using the Postman as a tool to test that. The next thing we're going to do is now build out the UI to look like what we had in the beginning. We have the Express server hitting the FastAPI. We're able to test it with Postman. Now let's integrate it with our React UI. So if we open up our localhost 3000, we have everything running. We have our FastAPI running in dev, we have our Express server running in dev, and we also have our client running in dev. If we look at what it looks like now, it's blank. But the end state we want to get to is something like this. So if a designer handed me this image and said, hey, can you please build this for us using React? We need all this functionality, and we need it to look like this. The most daunting part for me would be, oh God, I have to work with SCSS. I have to figure out the placement. I have to figure out how to create inputs that look like this or drop-downs that do this. And for me, that's difficult because I'm not really a great front-end developer. But what's really helpful is using something like Carbon, for me at least. So we know from the image we're looking at, we have something like a heading, and we have something like a combo box, something that has a drop down and that you could type in it and it filters it. We have a checkbox form, we have inputs, we have tags. The way I would do this, I would go to the Carbon React page and I would just look up stuff. So I know the first thing we're going to use is a heading. So when we open up a heading, very simple. The code is super duper simple. You just have heading. Let's add it to our React UI. So now from your directory, go to UI and then open up and then cd into client. Now in this client directory, we have a source directory, we have components, and we have a pet form. I have left in all the imports and a lot of the actual functionality for like state management and stuff like that, because what I'm trying to show you is how I utilize the Carbon design system to build out something like this. And then the functionality I implore you to look at, it's documented and you can figure out exactly what I'm doing. But let's start by looking at what we have. We have two columns, and this is all from Carbon. We have two columns, one for pet form and one for results. And we want to get to this end state. So let's start with the heading. So we already have it imported. We know it's going to be here. So we could just add heading. And we could say, what do we name it? Describe your future pet. Boom. Headings are simple. Like this stuff is okay. We could use an H1 or H2 or whatever, but having something that's using a design system that already looks good and you don't have to worry about it, you don't have to worry about the font, you don't have to worry about the sizing, you can just use it is so helpful, and it just expedites all of the work on the front end. The next thing we have to bring in is this combo box. So let's look at what the combo box available in Carbon is. And we can see it, they have it already here. Example of what it looks like. You have all the documentation. So let's look at this. So we have one that filters. We know that's what we're going to look for. So we could look at this exact code, and we could just grab something like that and bring it into our application. So for this one, we'll just bring this. Now we don't have items yet, so let's see what it would look like. We'll have an ID with a 1 and a text with first item. And then for the next one, we'll have an ID with 2 and a text with the second item. And so really, it's already built in. You have this items prop, and you just fill it in. It's looking for an array. And if you look at it actually has an explanation of what it's doing. It says they're trying to stay as generic as possible, and we could have a total control over it. But for us, we want something pretty simple. We want an ID and we want a text. So if we look at our application, once we save, we already have it. It's already built in. We have the first item and the second item. It's already filterable. Like it's just from the get-go, you could select it. We're actually going to add the filtering in a second. And that's how easy it is to add like complex components that look good into a UI using Carbon. I'm a big fan. So now let's just fill in all the functionality that we're expecting. And we have an onChange, and it's pretty simple. It's just looking at the selected item and it's setting it to our state. We have the ID, the items that we're using. Usually, like the way I would use this in an engagement is that we would often have an API call to a database and store it as the state for the items. So you could have, like, especially if you have a ton of rows from a database and you want to quickly filter it down, you could do that. What we did in this case is we just have just a giant list of different animals that you could potentially have as a pet, like an alpaca. So now that we have all of this, you can see that we have what it's going to be. We have all the different animals that we have available for it to being a pet, like a tarantula. And we can move on to the next item that we need, which is a form group with a couple of checkboxes. So similarly, if we go to Carbon, we can look up checkbox. We could show, we have skeleton, we have just regular checkbox, the way it looks. So let's grab the checkbox, we'll put it in a form group. And the form group is also, this is something that Carbon provides for us. Something interesting about a form group, I think it needs a legend text. So let's add some legend text, and we'll say pet gender. If we look at our application, we have our two checkboxes in the pet gender. And if we look at what it's supposed to look like, obviously we have to make it male and female. So let me add the functionality and readjust the label text. So now that we've added all the functionality that's included in the component, we'll just go over like simply what it's doing. So the checked means is just accepting, the way we're setting it up is just a Boolean. We're seeing if the state gender of animal equals male, that equals true, make it checked. And the onChange similarly is just saying, okay, if it is already male, set it to nothing. But if it isn't, set it to male. A really simple state change. We have a disabled while loading. So this is important because we don't want because let's say like an API call to the FastAPI takes like 6 seconds, which is pretty long for an API call. You don't want them making edits to the form while it's happening. So we disable all functionality within the form, and you'll see this over and over again as we get through, as we keep on adding functionality to this component. So now we have our pet gender. You could choose a type of animal. The next thing, now this is an interesting component. If you remember from the beginning of the video, how this works is this is an input field where when you start typing, the button on the right is activated. When you hit enter or you hit the button, it adds it to a tile at the bottom. And it's adding each individual descriptor and a little tag. Now all of this is pretty custom, but we're using the styling and the tags and the functionality is coming from Carbon. So we're gonna need an input and we're gonna need a button. So now I'm just gonna paste in the functionality for this and explain exactly what we're doing. So if you look at our application, we have the descriptor, add, cute, sweet, whatever you want, whatever your pet descriptor will be. And you can see as we're typing, it goes from disabled to not disabled. When you hit it, it clears the input field. And what you're not seeing, obviously, is that we are adding all of this to a descriptors list, which we're going to use to formulate that API call to the FastAPI. And so just for clarity, I could go to the I could go and I will add a use effect just to show you what is happening as we hit enter. And we're going to look at the descriptors state. And if you look at descriptors, it's just an array of strings. If descriptors or descriptors dot length, just return, but if not, console log. So we could watch what's happening in here in the console as we're adding it. So let's say we add cute, hit enter. We can see that we have a little, we have an array with one item, cute and sweet and nice. Now we can imagine how we're going to utilize this when we send that API call. So let's continue with the functionality. So in the text input, we added a functionality on key down, and this is just like naturally what you do. And this is something I found, like whenever I'm in an input field, I expect something to happen when I hit enter. And so we just added the on key down, really simple functionality, looking for a keyboard event. If the key that is hit is enter, you run the function handle add descriptor, which adds the input text into that descriptor array. And then obviously disable while loading. Same with the button. The disabled part is actually interesting. It's just saying, okay, if the input value and state is nothing, so that like the input length is nothing, just keep it disabled, or disable while loading. So that's the way we're able to dynamically disable and enable a button here. So we could say cute. The second the input length is no longer 0, we have a little button. Click it, back to 0 because it clears the input and adds it to the descriptor array. So what's the next functionality we need to add? So now let's map over that descriptor array and place it in this this tile. I like the tile. It's something that I got from Carbon. It's just it looks like a div with like just extra capabilities. I just happen to like to have the ability to have more capabilities, such as like, you could drop it down, you could add functionality to it, you can make it selectable. So in our case, what we're gonna do is we're gonna add a tile. And in that tile, we're gonna say, okay, look at descriptors, map over them, look at what it is, descriptor now, descriptor index, and return back something called a tag, which I really like. Again, it looks good, it has functionality, we can add an icon to it, which is what I want to do. So this is, if you look at the final result, we have that little tag with the descriptor and a little X. Now that filled in X, obviously it gives you the impression that you could click on it and delete it. And that's what we want it to do, because if you add something that you don't mean to, you want to be able to delete it. It's just nice functionality to have. So if we look at how to build out a tile with a, we just say it's just a tag with the class name of whatever and the content inside of it. Basically all it's doing is it takes a string, it looks at the descriptors, and we're gonna update whatever that list is as long as it doesn't equal the one that you just clicked. Really kind of simple. You're just filtering it down. So now that we've added that, let's look at how our application handles the additional descriptors. So cute, fast, and sweet. And on click is gonna, oh, and I added box shadow. Now, I like box shadow. I don't know why the modern UI design does not like box shadow, but I happen to like box shadow. I don't know why. I think it makes it look 3D. I think it's very cool. So we could click on the cute, click on fast, click on sweet, and you could delete it. And that's the functionality we're looking for. The last thing we're looking to do is have a button set. So let's add a button set to our component. So in the stack, we could just add button set, and we could have button clear, and we could have button submit. And all of this is coming from Carbon. So it's already automatically going to be sized correctly, and the button set's going to have the little gap. We have two different kinds of buttons, but if you look at the image, we have two different colored buttons, and within the Carbon React documentation, just go to button, and you can see something called kind. So you could choose what kind of button you want. So we want the submit to be primary, and we want the clear to be secondary. So let's just update this. Kind secondary, and kind primary. And there we go. We have the two buttons. The functionality for the submit will be done relatively quickly. So now that we have all the functionality there, we have the two functions. So the handle clear function is pretty simple. We're looking at all the state that we have in the component. We're just setting it to its original empty form. The disable clear button and disable while loading. You don't want to have, if there's nothing, we have some functionality in use effects that are just looking at if any of the state is filled. If nothing is filled, you shouldn't have the ability to clear, and you shouldn't have the ability to clear while you're making the API call. Similarly with submit, instead of disable when nothing is filled out, we have to disable the button when not everything is filled out. So you can't make a request if you don't have an animal, you don't have a descriptor, you don't have a gender. We need all of those in order to make that submit. So now that we have everything in the pet form at least visually completed, let's get everything in the result form also completed. We'll handle the functionality in just a second. Obviously, we need to add a heading for the result, which will just say result. What else do we need? And then we need these accordions, which I like. I like the functionality of accordion. They're dynamic. I think they look good. You could fill it in. You have the title, and then you have the content within it. So it's something that I thought would look kind of nice when we're displaying results. Also, they have the skeleton state, and I also like the way that looks. So I just put it in that way. It doesn't really have any necessary. You could render the response any way that looks good to you, but in my opinion, I liked the accordion. Okay, so now that I've just added all the functionality, we're looking at a loading state. Obviously, when you're making that call, you're making that API call, you set the loading state to true. And what that does is just it alerts the application and the component to switch between loading state and not loading state. And our loading state happens to be just these accordion skeletons that I just showed you here. So let's complete that. And now we have whatever we're looking for. We just have to wait to add the rendered results, and that's going to be the response from the API. And in order to get that functionality working, let's go to our handle submit, and we can see exactly what we need to do. So the first thing we're going to do is we're going to look at that list of descriptors, and so we're just going to grab the strings inside that list and just create a comma separated string by it. Pretty simple. We're going to say descriptor list, and we're going to say descriptors dot join comma separated, and now we're going to have a just a string that has all the descriptors in a string, comma separated string. So really what you're looking for, if we look at the FastAPI example, is just this input. We're looking to recreate that in our API call. So let's use this as reference. So now we have to interpolate all the data we collected from the form into a single string. So that should be pretty easy, right? So const string to send to API equals, we'll use backticks. We have the gendered animal state, so that would be either male or female. And then we'll say the type of animal dot text. So that could be a male dog who is, and then we just have the descriptor list. Great. So that's now all we have to do from here is make that API call. So let's set the loading to true. And all these state variables are of the state has all been pre-populated in the application. So all you're doing is running those hooks. So let's set loading to true. And let's make the API call. Similar to the way we did it in the Express API, but we know we're going to, if we look here, we're going to API/petnamer/generate petname, and we are going to send data string to send to API. Making it a post. Okay. Okay, so now that we have crafted the API call that we're making to our Express server, we now have to, on success, extract the relevant data from the response. So let's just go look at what we're expecting as a response on success. We're going to get a generated text and request sent to LLM. Now, if you remember from what we're showing, what we want the end state to be, the request sent to LLM is going to be this API call, like this object. And then we're also expecting a name and description in that generated text field. So let's look at our code in the React UI and anticipate what we're going to get. Something I really like about TypeScript is that it knows that the next part, result from Axios is going to be .data. I just find it very, very helpful. So it infers that this is an Axios response, and it gives us at least the first property on the data response that we could possibly use. The next one, though, and it might make sense just to copy this, so I could just reference it. Let's copy it. So we know that we're expecting a result.data.generated text. So let's call that object. And then we have the data sent to API, which equals result.data dot request sent to LLM. If there's anything I could do better, it's variable naming. I'm really terrible at it. Okay, so now we have the object that we want to render for the name and the description. And the next thing we have is that data sent to API, which is we want to render just as information of what was sent to the FastAPI. So we have both of these. And now we want to set the response name and description to state. So if we look at the accordions that we have placed in our response, let's see what we're expecting. So rendered results.name for the name, rendered results.description for the description, and then we're going to stringify the rendered request. Okay. So all of these are state. All of these have been included in state. So let's start with object. We'll set rendered result to object. And then for the rendered request, we'll set rendered request to data sent to API. And then we'll set the accordion to open. Open. Oh, perfect. We'll set that to true. And then we'll set loading to false finally. So once it goes through once it tries to do all of this, it sets the loading to true. It makes the API call to the through the Express server to the FastAPI. It returns back the generated text from that FastAPI to the Express and to the React handle submit function. We set the rendered result to the object that we received. And then we also set like the body that we sent to FastAPI just so we can see what it looks like. We set accordion open, so it's going to open up that accordion automatically. We're going to log an error, and we're going to set loading to false. So let's actually try the application now. We're going to choose a rabbit, female, cute, sweet, fast, and cowardly, and hides under my bed, and eats my books. Okay, let's submit it and see what kind of response we get back. Luna Bun Bun, and it gives you a description, and it shows us exactly what we sent. We sent this body to the endpoint. We're sending the data, a female rabbit who is cute, sweet, cowardly, and hides under my bed. But what happens if we have an error? Now, I've discussed that when we were making the FastAPI, that when you're trying to we're coercing the LLM to send back a JSON format, and we're doing that through that Pydantic output parser. And it's just like a really well-crafted prompt. But occasionally the LLM is just not going to send you back something that is actually JSON, and you'll get an error. So we want to kind of handle that. And there's a really simple way to do it. It's not particularly elegant, but it is simple. So let's create a new state, and we'll just call it error. Set it to false to start with. Boolean. Okay, let's go to handle submit. So we have this catch for this error, so we could console log it, but we could also set error to true. And then finally, set loading to false. Okay. And we'll also, if the way I'm thinking this working is that when we retry it, we'll set the error to false, so we don't continue to render what we're going to render. So let's set error to false. So let's go to that button set, and let's add a conditional rendering, right? Error, and let's add a new button. Instead of it will be the exact same thing as submit, but we'll change the kind. We'll make it danger. Okay, and we'll change this to retry. Let's just test this functionality. Let's, instead of sending back a good response, let's send a return res status 500. Okay. Let's attempt it and just make sure that it functions the way we expect it to function, because occasionally it will fail, right? Alpaca. So hopefully we get back a failure and it populates a perfect. Okay, so and what we want to do is when we click it, again, it's going to take it off. It's going to stop rendering it, and it's going to do another submit. That's perfect. So let's fix our Express server. Make sure everything is running. Let's try to rerun it. And now this time with the Express server actually returning back an accurate response. Snuggles the gentle. The name embodies the alpaca's undeniable cuteness and its sweet nature. That is a very nice name for an alpaca. So that was it. Now that you've seen how to build a full stack generative AI application, why don't you take what we did and make it better? Use what we've shown you today to create a new route, use new prompts and new examples, different model parameters, and come up with something cool. You know, something with like interesting functionality. Integrate it with a new UI to make it look awesome, and tell us what you're building in the comments. Honestly, thank you for watching, and if you like this video, be sure to like and subscribe.